CIET NCERT presents AudioBook, Maths Mela, Textbook of Mathematics for Grade 5.
Chapter 7, Shapes and Patterns, page number 92. On the right side of the page, we are provided with a QR code, scanning which we can reach out to additional resources to this chapter. On the right side, we are also having a picture of a girl holding a cube. Weaving mats. You may have seen woven baskets of different kinds. If you look closely, you will notice different weaving patterns on each basket. We will try weaving some mats with paper strips. First, let us make paper mats. You will need a colored paper 30 cm long and 20 cm wide, and 8 paper strips of 2 different colors, 3 cm wide and longer than 20 cm. A. Take a colored paper 30 cm long and 20 cm wide. B. Fold the colored paper in half along the longer side. C. Draw vertical lines at equal distances from the closed end and cut slits, leaving a gap of 3 cm at the top. D. Carefully unfold the paper. There will be no cuts in the paper at the top and the bottom. E. Now cut 8 paper strips of 3 cm width in 2 colors and of length slightly longer than 20 cm. F. Take one color strip and weave it across the slits, going one under and one over, and again one under and one over. Repeat it for the first row. G. Take one more strip of another color and weave it across the slits, going one over and one under, and again one over and one under. Repeat it for the second row. H. Weave all the strips in the same alternating pattern. Neatly fold any extra strip ends behind the mat. Your mat is ready. We can describe the pattern of the above weave as follows. Row 1, 1 under, 1 over, 1 under, 1 over, repeat. Row 2, 1 over, 1 under, 1 over, 1 under, repeat. On this page, we have pictures of 3 different baskets having different weaving patterns. We also have pictures of colored papers in which it has been explained how to fold it and make slits for making a mat. In the next 2 pictures, the method is described how the strip is to be inserted 1 over and 1 under in order to completely get the pattern of the mat. Page number 93. Second, can you figure out how to make this mat? Let us try to understand how this mat is woven by looking at the pattern in the first 2 rows. Row 1, 2 over, 1 under, 2 over, 1 under, and so on. Row 2, 2 under, 1 over, 2 under, 1 over, and so on. You can use strips of the same color or 2 different colors, one for each row. There is a picture provided of a mat provided with a pattern explained here. Third, try to weave a pattern using the rules given here. Row 1, 2 over, 1 under, 2 over, 1 under, and so on. Repeat. Row 2, 1 under, do not repeat. 3 over, 3 under, 3 over, 3 under, and so on. Repeat the pattern. Row 3, 2 under, 1 over, 2 under, and so on. Repeat. Row 4, 1 over, do not repeat. 3 under, 3 over, repeat. Continue weaving in this order. There is a picture provided for the weaving pattern here. Fourth, can you work out the steps for any of these designs and weave the pattern? Write the steps of the pattern in your notebook for each row until it starts repeating. Here we are provided with two pictures in which two different designs are there with different patterns. Let us try. Draw the following pattern on a grid paper. Part of it is done for you. Now complete the rest of the grid to get the full design. We are provided with a picture of a pattern here, and we are expected to complete the pattern in the grid provided beside it. Page number 94. Tiling and tessellation. We often use tiles of the same shape or a combination of shapes to cover a region. You can see pentagons, 5-sided figures in this figure. As all its sides are equal, it is a regular pentagon. Shapes that have equal sides are called regular shapes. We have placed 3 pentagons around a point. Can we fit one more into the empty space? Pentagons cannot fill a region without leaving gaps. So, we say that regular pentagons do not tessellate. On the right side of the page, we are provided with a pic having 2 pentagons connected in blue color and one green in color is adjacently placed along one side of the pentagon, where some portion of the slit is leaving a gap. Find out, can regular triangles fit together at a point without any gap? How many of them fit together? A sample triangle is given at the end of the book. Do you notice that regular triangles fit around a point as given here? Regular triangles, when fitted around a point, leave no gaps and there is no overlap. Triangles with all equal sides are also called equilateral triangles. Therefore, equilateral triangles tessellate. Can squares, a regular 4-sided shape, fit together around a point without any gap or overlap? Try it out using cutouts of squares. A sample square is given at the end of the book. How many squares did you need? Can 5 squares fit together around a point without any gaps or overlaps? Why or why not? Here we also have a picture of a hexagon formed by 6 triangles joined together without leaving any gap. Can regular hexagons, 6-sided shapes with equal sides, fit together around a point without any gaps or overlaps? Try and observe. A sample hexagon is given at the end of the book. How many fit together at a point? We are provided with a figure of a regular hexagon here, which is blue in color. Page number 95. Here is a tessellating pattern with more than one shape. What shapes have been used in this pattern? We are expected to write down the shapes in the blanks provided. We are also provided with a picture of a tessellating pattern having hexagons and triangles around the sides of a hexagon. Continue the pattern given here and color it appropriately. We are provided with a dot grid in which we can find the hexagons and triangles on the sides of the regular hexagon. A regular octagon means a shape with 8 equal sides. Do regular octagons fit together without any gaps or overlaps? Try drawing the same and check. Regular octagons do not tessellate. We are provided with a picture of a regular hexagon which is green in color on this page. Page number 96. Observe the pattern given here. What shapes are coming together at the marked points? Are the same set of shapes coming together at these points? Continue the pattern and color it appropriately. We are provided with a dot pattern here. In this grid, we can find the octagons have been arranged and the gaps have been filled up by rhombus which are blue in color. Octagons are not regular but they are green in color. Here is a tiling pattern made using two different shapes, squares and triangles. Are the triangles equilateral? Why or why not? Here we have a dot grid in which we can find three different squares and two triangles which are tessellating with the squares. What shapes are coming together at the marked points? Are the same set of shapes coming together at these points? Continue the pattern and color it appropriately. Create similar patterns using other cutouts of shapes. A rhombus is a shape with all equal sides. It has been divided into 4 triangles. On this page, we are provided with a picture of rhombus which is formed by 4 right triangles. Page number 97. You will find a copy of this rhombus at the end of the book. Cut out the triangular pieces for the following activities. What geometrical shapes can you make by fitting 2 of these triangles together? Trace the shapes you created. Here, there is a blank space provided to you to create different geometrical shapes using triangles. Question number 1. How many different types of triangles can you make? Now, observe and measure the sides of these triangles. What do you notice? Each triangle has 2 equal sides. Such triangles are called isosceles triangles. Trace the isosceles triangles on a paper and cut them out. Fold them in half. What do you notice about their angles? Each isosceles triangle has 2 equal angles. Question number 2. Is it possible to make a triangle where all 3 sides are equal? Within brackets, equilateral triangle. Question number 3. Is it possible to make a triangle where all 3 sides are unequal? Try this. Cut the equilateral triangle provided at the end of the book. Check if all the angles of an equilateral triangle are equal, just like you did with the isosceles triangle. Equilateral triangles have equal angles. Now, cut the equilateral triangle in half. How many sides of each new triangle are equal? Triangles that have no equal sides are called scalene triangles. Check in scalene triangles whether any 2 or more angles are equal. Here we are provided with 3 different figures in which we find an equilateral triangle is there, and in the next picture we have an equilateral triangle which is cut into 2 equal parts, and in the third one these 2 different triangles have been separated after cutting in the middle. Note for teachers: encourage the learners to use paper folding methods to compare the angles of a shape. Page number 98. Question number 4. How many different 4-sided shapes, that is quadrilaterals, can you make? Here are 3 possible shapes. Have you made a shape like the one given on the right? This shape is called a kite. What do you notice about the sides of a kite? Side 1 is equal to side 2. Similarly, side 3 is equal to side 4. These sides are called adjacent sides. Here are two other possible quadrilaterals that are not kites. On the right side of the page, we are provided with a picture. The two triangles are joined to form a quadrilateral in which side 1 is equal to side 2 and side 3 is equal to side 4, and the shape resembles a kite. We are also having two more pictures on this page of two different quadrilaterals. In quadrilateral A, we have a quadrilateral which is in the shape of a parallelogram, and in B, we have another quadrilateral which is in the shape of a rectangle. Question number 5. Measure the sides of each of these two quadrilaterals, A and B. What do you notice? Are there any pairs of sides that are equal? Which pairs are equal, adjacent or opposite? Quadrilaterals whose opposite sides are equal are called parallelograms. What type of angles do quadrilaterals A and B have? Which angles are equal in each of the above parallelograms? In parallelogram A, opposite angles are equal. In parallelogram B, all angles are equal and are right angles. Such a parallelogram is called a rectangle. A rectangle is a special type of parallelogram. Page number 99. Question number 6. In the grid given here, draw two different kites and parallelograms each. We are provided with a grid here which is blank, and you are expected to draw different kites and parallelograms. Question number 7. Now use three triangles from the rhombus to form shapes. How many sides do each one of them have? Using three triangular pieces of the rhombus, try creating A. three-sided shape, B. four-sided shape, and C. five-sided shape. Question number 8. Which of these shapes can be made with all four pieces? Try and find out. A. Square, B. Rectangle, C. Triangle, D. Pentagon within brackets five-sided, E. Hexagon within brackets six-sided, F. Octagon within brackets eight-sided. Tangram. Observe the tangram set given at the end of your textbook. Cut out all the shapes. Name them. A. How are they same or different from each other? B. What do you notice about the angles of each of the shapes? C. What do you notice about the sides of each of the shapes? On the right side of the page, we are provided a picture of a tangram having different parts in different colors. Now use some or all the pieces of your tangram set to make the following shapes. There may be more than one way to do it. Here we have pictures of different shapes which have parallelogram, rectangle, triangle, and a trapezium. Page number 100. Which shape am I? Match the statements with appropriate shapes. Do some of them describe more than one shape? Here we are provided a box which is having three different columns. First column is for serial number, second column is for statement, and third column has the shapes. Now first statement is all my angles are right angles, but all my sides are not equal. Second statement is all my sides are equal, but all my angles are not. Third, my opposite angles are equal, but my sides do not make a right angle. Fourth, two pairs of sides are equal, but they do not make a right angle. Fifth one, all my sides make right angles with each other and are equal. Sixth, my opposite angles are equal and so are my sides. Statement 7, my opposite angles are equal and my sides make right angles. In the third column, we have pictures of 4 different shapes. First one is a square, green in color. Second is a rectangle, which is pink in color. Third is a rhombus, blue in color. And fourth is a parallelogram, which is yellow in color. Kites. Make your own kite shape. A. Start with a square piece of paper. B. Take one corner of the paper and fold it towards the opposite corner, creating a sharp crease along the diagonal. C. Open and fold the corner A inwards, aligning the edge with the crease you just made. D. Repeat on the other side, folding the other corner B inwards to align with the crease at the center. You have a kite shape. What shapes do you observe in the kite? Towards the right side of the page, we are explained how to prepare a kite. There is a yellow paper which is being folded along the diagonal, and the opposite vertex A and B are supposed to overlap after folding. And in the next step, it is explained how it is to be folded along A and B to give the shape of a kite. Page number 101. Play with circles. Do you remember a circle? A. Draw a circle with a compass and mark its center. B. Draw its diameter. Mark the ends of the diameter. C. Draw another diameter of the circle and mark the end points. D. Now join the 4 points. What shape is formed? Check the sides of the quadrilateral and the angles obtained. Try with a different pair of diameters. What do you notice about the shape that is formed? Is it possible to create a 4-sided shape other than a rectangle through this process? On the right side of the page, we are provided with a picture of a circle and 4 dots on the circumference of the circle. The diagonals are joining, passing through the center. We are also joined with the line segments to form a rectangle. Circle designs. Observe the circle given here. It is marked with points 1 to 24. Join points 1 to 11, 11 to 2, 2 to 12, and so on till you reach back at 1. Try it with different colored threads on a thick paper or cloth. Here we are provided with 3 different pictures in which the steps have been explained. In the first one, we can observe that it has 24 points and point 1 is joined with 11 and 11 is joined with point 2. In step 2, we can notice that point 2 is joined to point 12. And in the third step, we can notice that point 12 is joined to 3. Can you think of a way to make a design exactly like the image given here? Try to make it. There is a beautiful picture formed with the help of circles. Page number 102. Cube connections. Question number 1. Here are 3 views of a cube. Can you draw them on the net in the correct order? Here we have a picture in which we find 3 cubes on which different faces have different patterns like plus, circle and a square and a star on different faces of a cube. On the right side, we have a net of a cube. Question number 2. Here are some big solid cube frames. How many small cubes have been removed from each cube? A. Here we have a picture of a 3 by 3 by 3 cube, and in the next picture we have one cube being removed from the center. In B, we have a cube made up of 4 by 4 by 4 cubes, that is 64 cubes, and in this we find that 2 by 2 by 2 cube has been removed from the center. In figure C, we find a cube made up with 125 cubes, that is having dimensions 5 by 5 by 5. Here we can find that the cube of dimensions 3 by 3 by 3, that is 27 cubes, have been removed from the center. Question number 3. Nisha has glued 27 small cubes together to make a large solid cube. She paints the large cube red. How many of the original small cubes have A. 3 faces painted red, B. 2 faces painted red, C. 1 face painted red, D. No faces painted red? We are also provided with blank spaces in front of each, and we are expected to write the answers there. Puzzle. Tanu arranged 7 shapes in a line. She used 2 squares, 2 triangles, 1 circle, 1 hexagon and 1 rectangle. Find her arrangement using the following clues. A. A square is between the circle and the rectangle. B. The rectangle is between the square and the triangle. C. The 2 triangles are next to the square. D. The hexagon is to the right of the triangle. E. The circle is to the left of the square. Page number 103. Icosahedron and dodecahedron. What do these names mean? Once you count their faces, you will know. Use the nets provided at the end of the book to make icosahedron and dodecahedron models. What shapes do you observe in an icosahedron and dodecahedron? Icosahedron blank, dodecahedron blank. We are expected to fill the blanks. Do all the faces appear the same? Icosahedron blank, dodecahedron blank. We are expected to fill these blanks. How many faces meet at the vertex point? Icosahedron blank, dodecahedron blank. Do the same number of faces meet at each vertex? Icosahedron blank, dodecahedron blank. How many edges do you observe? Icosahedron blank, dodecahedron blank. How did you count them such that you do not miss out any edge or count an edge twice? Can you think of any other solid shapes that have faces that appear the same? Do the same number of faces meet at each common vertex? There is a blank provided here for you to write down the answer. You can also build some 3D shapes using straws or ice cream sticks and clay or play dough. Which shapes did you make? We are provided with 3 different shapes which are made of the straws and the clay balls. On this page, towards the right side, We are also provided with two pictures of icosahedron and dodecahedron. Chapter 7 ends here.
Maths Mela. You were just listening to this audiobook. Textbook of Mathematics for Grade 5. Narration Swarnlata Sharma. Sound recordist Ekant Vashisht. Production assistant Amarjit Sarkar. Directed and produced by Vimlesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.